Hello all, welcome back to our YouTube channel. Today we're gonna see about harnessing deep learning for accurate plant leaf disease detection and management. First, I'll explain your abstract. Here, our abstract summarizes that plant disease are a major challenge to global food security and agriculture productivity as they can lead to significant crop losses. Traditionally, farmers and experts identify plant disease through manual inspection, which is both time consuming and prone to human error. Deep learning, especially CNN, has emerged as a reliable solution for automating plant disease detection by analyzing image of affected crops. This study presents a structured approach to detecting and managing plant disease using deep learning technique. The process being with data collection from a various source, followed by pre-processing steps such as image augmentation and noise removal to enhance the quality of input data. CNN architecture are selected for model training and transfer learning is used to improve accuracy even when working with limited dataset. The model performance is assumed with cross-validation and key evaluation metrics like accuracy, precision, and F1 score to ensure its effectiveness across different plant species and disease types. Once trained, the model is deployed for real-time diseases detection, allowing farmers to identify cross disease early through mobile or edge computing devices. Additionally, the system provides disease management recommendation, offering actionable solutions such as chemical, biological, or cultural controllable methods. Here, I will explain our introduction. Our introduction summarizes the problem of this plant disease and their impact, where, where a global food security and agriculture productivity. It highlights the traditional methods of detecting plant disease rely on manual inspection, which is often slow, labor intensive, and prone to error. This makes it difficult for farmers to take timely action, leading to significant crop losses. To address these challenges, deep learning, specifically CNN, has gained popularity as a powerful tool for automated plant disease detection. CNN analyzes plant leaves, stems, or fruits to identify diseases with high accuracy. The study proposes a symmetric approach that involves collecting plant disease images from various resources, preposing, preposing them using techniques like augmentation or noise removal, and selecting suitable CNN architecture for model training. Here we improve accuracy. The study utilizes transfer learning, which allows pre-trained model to be fine-tuned on a smaller data set, making this system more efficient even with limited data. The trained model is then evaluated using performance metrics such as accuracy, precision, and F1 score to ensure it work well across different plant species and disease types. Once validated, the model is deployed in real application, enabling farmers to detect disease using edge computing technologies. Here, our problem statement summarizes that a traditional plant disease detection, such as manual inspection and classical machine learning technique, are often inaccurate, time consuming, and inefficient for large scale farms. Existing deep learning models requires large label dataset and computational resources, making real time implementation challenging. There is a need for a robust and scalable AI based system that can accurately classify multiple plant disease and provide actionable treatment recommendation. Farmers often lack access to expert consultation, leading to delayed disease identification and improper management. The project aims to develop a VGC16 based deep learning model for classification 5 plant disease or offering causes analysis and efficient management strategies, ensuring improved agriculture productivity. Here's a proposed system and here's a system workflow. First, we'll do data collection and we'll do pre-processing such as resizing and rotational flipping. These are all comes into our pre-processing and we will do model selection and training. here we are selecting a VG16 model. After VG16 model, we do a trained data so that it could be evaluated and the evaluation metrics will be found which has a great accuracy and will take that model into deployment. That's what I'm doing here. After deploying, we'll do disease prediction and classification. After that, we will analyze the cost and we'll do recommended system to the cost. That's what I'm doing here. Here's a block diagram. First, we will do data collection. From cattle, we have took the data and we will do pre-processing thing and we'll segment the deceased thing separately by using segmentation and we will do model training. In this model training, we're going to work with VD16 model and we are doing model evaluation. From that evaluation, we will know how much accuracy you have gained and we're taking into that we're taking that model into testing and we're testing with new images. In this we can do prediction like which image like the predicted images is cost this thing so that we get from that we can take one of the recommendation and the causes because of why this is happening we can take here and we'll do result as this. Now I'll show you our training code once you can see. Before that I will show you our data set. This is your data set. Totally five classes I have. This is bacterial spot. These are the bacterial spot, the black rod, common rust, poultry mildew, spectoria leaf spot. You want to train this image in testing pool, in training pool. This is our training pool. This is our training code. This is nothing but our data set part. And here we are doing we're fetching our file names. That's what we're doing here. And then every images will be trained as 128, 128 width and height. And this is epoch. Totally 50 iteration will be done. And this is batch size. How much samples should be going for? How much samples should go for one epoch? That's what is iteration here. That's batch size. And here we are doing a VB16 model and you are compiling the model and we're using augmentation here. That's what we're doing here. And then from here we are creating a function called we are importing a function by using our exaflow function callback function called model checkpoint. In this we can retrieve a best V16 model. That's what we're doing here. And then we are training the model here. Finally, our full model is known as VG16 trained model and H5. And finally, we are taking our best VG60 model here. From this model, we are doing confusion matrix. In this confusion matrix, you can see like how much is truly classified and how much is misclassified. You can see here. And then we are saving a classification report. Now I will show you our classification report and confusion matrix structure now. This is the confusion matrix we have got. And this is our model accuracy. Our training accuracy got up to 95 accuracy, and our validation up to got our 92 accuracy. And this is a model loss. This model loss is also good. Now test one of the images you can see once. This is our testing code. I'll test this now. You can see. Yeah, this is our GUI. GUI. You should click predict. And you should select any one of the images. I want to select this image. Okay, you can see the selected images back to your spot and the costs. Yeah, you can see the costs of back to your spot and plans and precaution also we have given. You can see this. I'll test another image, common trust. Yeah, yeah. The predicted image is common trust and confidence score we got up 98 and causes the cost of common trust in plans and precaution also we given here. Yeah. Thank you for watching our Aislyn Technologies YouTube channel. If we have more queries about this project, you can leave a comment in comment section and don't forget to like, share and subscribe. Thank you.